So this is a continuation, or I guess the completion of the notes about velocity and other rates of change. And so at the end of the last video, we had done a little bit of that, a little bit of this question. So now I'm going to finish all of these 28 things that it asks about this graph. And so we'll just want to review real quickly. We have a graph, and we know it's the velocity graph. And I told you that a really good idea is to write velocity once you determine that, because it helps in your mind to see that it's velocity. And then we also wrote those, the 0, the minus, and the plus. We wrote those in because that represents the acceleration. So we're just showing those slopes there in order to help answer some questions. And so then the next question, the questions that we answered at the end again of the video is, when is it moving constant? When is it moving to the right, moving to the left, speeding up and slowing down? And so I do want to stress again the particle speeding up and slowing down, that the one and only way that we should be determining that and giving as a reason is because velocity and acceleration have the same sign, or velocity and acceleration have opposite signs. And we are going to be in the habit of always answering and giving a reason for every answer. Okay, so let's go ahead and look at the next one. So 6 says, when is the velocity increasing? Okay, so back to the graph. Okay, looking at the graph here, the velocity is going to be increasing if its derivative is positive. Okay, because velocity is this graph. So if its derivative is positive, then this graph is increasing. Then this velocity would be increasing. Well, its derivative would be positive from 3 to 5 because the velocity graph is increasing there, which means that its derivative would be positive. Okay, so that's when so two ways to think about it. Either when the acceleration is greater than 0, or you can see the velocity graph is increasing. But we want to give a math way to answer that question, so we are going to say that it is from 3 to 5, and then remember, it doesn't matter if you do intervals like that or you do 3 to 5. You can say that, and we would say because, and you could say a of t is greater than 0 there. Or you could say the graph is increasing, and the graph is the velocity. But we usually want to talk about it in terms of calculus, in terms of its derivative. Then 7 says, when is the velocity decreasing? So again, for your same things, it would be when t is from 1 to 2, or also from 2 to 3. Now, we're not going to get into a big, huge discussion about what happens at 2. You could just simply say from 1 to 3, and that's because the acceleration at those places would be less than 0. Now technically at 2, the acceleration could have an issue because we don't really have a derivative there, but the College Board does not require us to include endpoints. So you can say 1 to 2 and 2 to 3, that'll be fine. And then you will give your reason as because a of t is less than 0 there. Again, or you can also say 1 to 3, and then it says, are your answers on 6 and 7 the same as your answers on 4 and 5? So 6 says 3 to 5, velocity increasing. 4 was particles speeding up, and that was from 2 to 3. And so, no, that's not the same thing. So again, speeding up doesn't mean velocity is increasing, because velocity also has a direction. So the only way a particle is speeding up is if velocity and acceleration have the same sign, okay? So, and then the same thing would be true for 7, okay? Same thing. It's not to do with that. So the reason the answer is no is velocity increases where acceleration is positive, and then also equivalently, and we won't write that right now, but decreases when acceleration is negative, not when the velocity is increasing. Okay, so it's important to remember that because velocity has a sign and it also talks about direction, so that makes a difference. Okay, number 9 says, how fast is the particle moving at time t equals 4 and in what direction? So if we look at t equals 4, this is the graph of velocity. So when we look at t equals 4, the value that we get, which appears to be -5, is the velocity, and the speed is just the absolute value of that value, because this graph is velocity. We don't have to take a derivative or anything. So therefore, the speed of it is the absolute value, and this is how I would want to write that. The absolute value of v of 4 is how fast the particle's moving, which is going to be 5. And then it says in what direction, and you would say in a negative direction, or since this problem said the particle positive is to the right, you could also say to the left. Okay, so if I didn't know that the particle was moving right and left, then I could just say it's in a negative direction because the velocity is negative there. So the velocity at time 4 is -5. And you don't have to give a justification for that because that's just directly off the graph. We're not making any assumptions, but this is the proper way to write it. And we do need to learn to speak in math, so we need to use the math. So velocity of 4 at 4 equals -5. Now you've answered the question and given all of the information they need. Okay, so 11 says, what is the average velocity over the time interval from 2 to 3? So again, looking at our graph, if I'm going from 2 to 3 and I want to know the average velocity, then what we're actually going to find is the area of this shape right here. So the area between the curve and the x-axis. And we're going to give the signed area. So in other words, the area, but then it'll be negative because it's underneath. Okay, so that's going to give me the average velocity. So average velocity from 2 to 3 is, and it would be 1/2 1 times -10. So just using the triangle formula, 1/2 base times height, which would then be -5. So that's the average velocity that you would have there. Then 12 says, when does the particle change direction? So remember that velocity tells me the direction that it's going. And so the velocity is positive up here. This is not the particle's movement. That's the velocity is positive. And down here, the velocity is negative. So that means this is where it changes direction, okay, when it equals 0. And so the reason you would say it changes direction, though, is velocity changes from positive to negative there. So we're going to answer when it happens. So we're going to say at t equals 2, because velocity changes from positive to negative. Okay, so it changes from positive to negative, so we know it changes direction. 13 says, how far does the particle move during the first second, and which way does it move? Okay, so we want to know how far it moves in the first second. So the distance that it moves would be the area underneath during this first 1 second. So this area here would represent how far it went, and then they want to know which way it went. Well, it's all positive. It's moving to the right. Okay, so it moved to the right. So this would be how far it moves would be 5 units over some time. Now they didn't give us any units here, so you could just say it's whatever units over time. If we talk about how far it moves, actually it's how far it moves wouldn't be, it'd just be 5 units, so whatever it is, and then it would be to the right, wouldn't be over time, and we would say it's to the right because it's positive. Okay, so we would need that area, and that would be how far we moved. All right, how far does to the right does the particle go, and when does it arrive there? So again, the particle is moving to the right in this area. So if I want to know how far it goes to the right, I need the area underneath this entire place. And so I know that it goes 5, because I just found the first part, plus half of 5, 2.5. So it goes 7.5 units, whatever the units are, we don't have any. And it's at time t equals 2, whatever units those are if we have them. Okay, so we're just going to add up those two things. 15 is going to ask me what is the total distance traveled by the particle. So looking at our graph, and we want to know the total distance traveled by our particle. So remember that distance traveled is absolute value of the areas that we're going to find, or the area under the curve, or thinking in direction. So we're going to ignore that some of it's underneath, because if it's underneath, technically it's negative. But we know this was 7.5 because we just found it. This is a big triangle that is 1, 2, 3 units wide by 10 units deep. So 3 times 10, and then half of that is 15. Now, it's technically negative 15 because it's underneath, but since it's distance, we would want to keep that positive. So it would be 7.5 plus 15, or 22.5 units. That's the total distance traveled. Now, 16 says, what's the particle's position? So position is different. We go 7.5 to the right, and then we go 15 to the left. This one, 15 is negative, so we go to the left. So our position is going to be, our displacement is going to be, it's 7.5 units to the left. Now, don't say its position is negative 7.5, because we have to know the starting position in order to know where it ended up. And we don't know the starting position, we just have this graph. So we don't know where it started. Nobody said, okay, it started at 5, or it started at 8, or we don't know where it started. All we know is it went 7.5 to the right, and then it went 15 to the left, okay, because of the negative 15. So its position is 7.5 minus 15, which is negative 7.5, but that's not really the right answer. So we would say it is 7.5 units to the left. That's its displacement after 5 seconds. So wherever it was, it's now moved 7.5 to the left. Okay, so we don't have the initial starting position here. So all we know is how it moved. Okay, so that's the difference in distance and displacement. Because distance is like I'm walking forward and I'm walking backward. If I walk forward 7.5 steps and backwards 15 steps, I still walked 22.5 steps. But if I walk forward 7.5 steps and then backwards 15 steps, I'm 7.5 steps backwards from wherever I started. Okay, so that's displacement. So don't confuse the two. Make sure you know the difference. Okay, 17 says, what is the average velocity of the particle over the 5-second time interval? So what we would want to do to find average velocity is we would take displacement divided by time, because velocity is displacement over time. That's what velocity is. So the average velocity is how much displacement in those 5 seconds divided by the 5 seconds. And so we end up with negative 1.5, and that's going to be the average velocity of the particle. Now you would get units over time. So if it's, feet and seconds, it would be feet per second. That would be the average velocity. Then the question on 18 again is, are your answers to 15 and 16 the same? 15 and 16, one is distance, one is displacement, and no, they're not the same, okay? 19 says, what is the average speed? Well, speed is distance divided by time, okay? So difference is velocity is, the average velocity is the displacement over time, and the average speed is the distance over time. Okay, so that's the difference there. So that's an important distinction. This is distance over time, and distance was 22.5. That's the total distance our little particle went, divided by the time of 5 seconds, which is 4.5. And then the question for 20 is, what was the particle's acceleration in the first second? So in the first second, the particle's acceleration, well, remember that acceleration equals the derivative of the velocity. So the derivative is the slope of the tangent line. So the slope in the first 1 second is 0. So the particle's acceleration in the first 1 second, the acceleration equals 0. Okay? All right, acceleration is 0, and the reason, what does the answer mean? And that means that the velocity is constant. Now, it doesn't mean you're not moving, but think of it like cruise control in your car. You're not accelerating, you're just going a constant speed. And then when you need to push the accelerator, you speed up, so you are accelerating. But now the velocity is constant, so it doesn't mean it's not moving. It just means that it's not changing. It's just going constant. 21 says, over what time intervals does the particle have positive acceleration? So again, what I just erased, I'll write again, that acceleration equals the derivative of the velocity. So if I want to know when is the acceleration positive, I want to know when is the derivative of this graph positive. So the derivative is positive on the interval from 3 to 5 because that's where velocity increases. So over what time intervals would be from 3 to 5, and our reason would be because velocity increases. Because remember, the acceleration is the derivative of the velocity. So if the velocity is increasing, its derivative is positive. And that's what we ask. When do we have positive acceleration? 22 says, when does it have negative acceleration? So 1 to 2 and 2 to 3. And again, this is where the velocity decreases. Okay, so again, because the acceleration is the derivative of the velocity, so if the velocity is decreasing, its derivative, acceleration, would be negative. All right, 23. When is the acceleration undefined on the interval from 0 to 5? So again, let's look at our graph. When you look at the graph, the acceleration is, again, remember that the acceleration is the derivative of the velocity. So the acceleration is a derivative of this graph that we're looking at, because this graph is velocity. So we know that we are not going to have a derivative here, and we're not going to have one here, and we're not going to have one here, because those are those pointed places. So its acceleration is going to be undefined from t equals 1, t equals 2, and t equals 3. And your reason would be because no derivative there. Okay, or you could say there are sharp corners there, so there's no derivative. We should technically say that the limits are different from both sides of the derivative, but that's what we need to do for this question here. We'll shore up some of that as we go through the semester. Okay, find an interval where on 25, oh, sorry, I wrote this in the wrong place. This goes up here. Acceleration's undefined. 24 says, state an interval of time when the particle has positive acceleration but is slowing down. So again, this graph is velocity. Acceleration is the derivative of this graph, or the slopes of the tangent lines. So the acceleration is positive when the slope is positive. The only time the slope is positive is from 3 to 5. So this is the only time that the particle has positive acceleration, and it is also slowing down there because acceleration is positive, but this graph is velocity, so velocity is negative because this is underneath. So again, we would say from 3 to 5, and our reason is acceleration is greater than 0, but velocity is less than 0 there. Okay, and so that means it's slowing down. And again, think of it because it's two different directions. We've talked about it with throwing a ball in the air. If you throw a ball in the air, as the ball goes up, the velocity is positive because you're throwing it up in the air, but acceleration, which is gravity, is negative, and that's why the ball slows down as it goes up. And then as the ball starts to come back down, the velocity is negative now because it's coming down, but the gravity is also negative, so it speeds up as it comes down because they have the same sign, okay? So if we want to do acceleration negative, but the particle is speeding up, the only place that would happen is both of these places have negative acceleration, but this one down here also has negative velocity, so that won't work. So, oh no, it's speeding up. Sorry, we're speeding up, so this one is the only one that does work because this is negative acceleration and negative velocity. So my answer is from 2 to 3. And again, the reason is acceleration is less than 0 and the velocity is less than 0. Because remember, this graph is velocity and the graph is under the x-axis there. Okay, 26. Oh, we're missing those questions. Here it is. I guess it got skipped. All right, 26. What is the particle's acceleration from 3 to 4? So from 3 to 4, the acceleration is the slope of this graph, and this is a line, so we just need the slope of the graph. So it appears to be, I think that's supposed to be at -5, and that's at -10. And so we have a, if we go from 3 to 4, we're going up 5 and right 1. And so our acceleration is going to be 5. And then at 27 says, what's the particle's average acceleration over the entire 5-second interval? So average acceleration would be slope of the entire, or the rate of change of the entire thing. And acceleration is the change in velocity over time. So the average acceleration would be velocity at 5 seconds minus velocity at 0 over 5 minus 0. The entire rate of change over the entire graph, which would end up being -1. And then, again, you would have units here if we had units. It says, over what time interval is the particle's velocity decreasing at a rate of 5 feet per second every second? Well, that's assuming our units are in feet per second. So assume that's what our units are, our feet and seconds. It says, when is the interval, or when is the particle's velocity decreasing at a rate of 5 feet per second per second. In other words, when is the slope of this graph 5? And that would be from, and then it's decreasing, so actually -5, and that would be from 1 to 2, because we have a rise of 5, or a rise of -5, I guess, and a run of 1. So we have -5 there. So that would be from 1 to 2, because it said when is it decreasing at 5 feet per second every second. So that would be the slope. When is the slope of the velocity? -5. That's kind of what they're saying. Okay, so now let's go back to this. This says complete the table below to talk about all possibilities for an object's motion. Okay, so we're just going to look at the different things. So the first one says, so this first column here says acceleration is positive. And then we want to do all the different velocities. So if acceleration is positive and velocity is positive, we know that our particle speeds up. They have the same sign. If we have positive acceleration and we have negative velocity, then your particle slows down. And then if we have acceleration is positive but velocity is 0, then we know we have stopped accelerating. So we've stopped moving right or up. Okay, we're going kind of right or up, I guess. We don't really know that. Just we've stopped accelerating, I guess is the best thing to say. Okay, so the acceleration is positive, but the velocity is 0. It just means the acceleration has stopped. Second column here, we have acceleration is negative, but velocity is positive. So we know that means we slow down. And then if acceleration is negative and velocity is also negative, then we your little particle is speeding up. So he speeds up. And then again, we have stopped accelerating if the velocity is 0. Then we have acceleration is 0. Well, if the acceleration is 0, then we know that we have a constant velocity, because the acceleration, again, is the derivative of the velocity equation. And if the acceleration is 0, then we know we have constant velocity. The one thing we could say is that the motion is that the particle is then definitely moving to the right here, and we know that because the velocity is positive in this column. Here we would still have constant velocity. The acceleration is 0, but we would also know that it is moving to the left at a constant rate, okay, that's not changing. And then if the acceleration is 0 and the velocity is also 0, we know that we are stopped, because there's no acceleration and there's no velocity, so we are not moving. All right, so let's talk about some of our terms here that are very important. And so this is going to be something that you're going to possibly want to put in your composition book, especially if you start getting confused. Now, if you don't really ever have any issues with this because of physics, you kind of understand all this, you're good. If not, I would suggest even cutting out this little chart out of your notes, because you're just going to be getting rid of some of the questions that you answered on that thing, or I would just copy it down. Okay, so I would say that we would want to put this in our composition book, and we want to write down the different things. So displacement is the change in position, and we use S generally for position, sometimes X, mostly more in physics than we do in calculus. We usually use S. So it would be S of B minus S of A. So it's just the change in position from the end of the interval to from the beginning. Average velocity is displacement over the elapsed time, the time in the interval that you're doing the average, or S of B minus S of A over B minus A. And that's also the slope of a secant line, because you're connecting points that aren't that are different points. So that's the secant line when you connect them. Velocity is the derivative of the position equation or the slope of the tangent line. Okay, speed is the absolute value of velocity, which is ds dt, the derivative of the position equation over time. That's speed. The distance traveled is the sum of the absolute values of all the distances between turning points. So thinking about I'm going forward and backward and moving right and left, then I have to take those absolute value of all of those different times that I turn. The direction will change for a particle whenever the velocity changes from positive to negative or negative to positive. It does not have to go through zero in order to change direction. It could be undefined there. Okay, so zero or undefined places are what we will look for possible places it changes direction. Okay, so let's do this example 7. So this is talking about velocity and speed. This is a calculator question. So you're going to want to use your calculator to do these. And when we use the calculator, we definitely use the calculator, which means that we simply write down what we're doing and then we write the answer down. We do not do things by hand. We don't write down the answer that we get. We just write it down. So let's see this example and I'll show you how to write it, and then you should practice and put it in your calculator. So we have a model rocket. It's launched vertically upward from the ground with an initial velocity of 114 feet per second. The position of the rocket can be modeled by this equation. Okay, so this is our position equation. Then A says find the velocity and the speed of the rocket at t equals 5 seconds. Okay, so to find velocity, here's exactly what you would write. You would say the velocity at 5 equals s prime at 5 equals, and you write whatever you get in your calculator. So you have told somebody everything you're doing. You have told somebody that you are aware that the velocity is the derivative of the position equation. So you've given that information and you're evaluating it at 5. It's a calculator question, so we do not do anything except put it in the calculator, and then always, always, always we include units. So very important to remember that. Units, 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 units. Okay? B, is the rocket speeding up or slowing down at t equals 5? Well, the only way we're going to know that is to compare the velocity and the acceleration. Well, we know that the velocity at 5 seconds is negative 46 feet per second. We just found it. So what we want to do is find the acceleration. So what we're going to do is say that we want to do the acceleration at 5 seconds, which we know is v prime at 5 seconds, because again, you're just telling somebody I'm relating that to velocity, and then we do it in the calculator and we get negative 32 feet per second squared. Okay, it's acceleration. And so what would we conclude there? Well, velocity is negative, acceleration is negative, therefore we would answer the question at t equals 5. When you answer questions, you always have to answer with units and when it happened, like at the time interval or at this x value or over this interval or whatever it is. Always give when and units. So at t equals 5, the rocket is speeding up, and then give your reason. Since velocity at 5 is less than 0 and acceleration at 5 is less than 0. And it's not bad to put parentheses, same signs. Like, it's good to kind of say that. They have the same signs. But I wouldn't just say they have the same signs. Better to say velocity is negative, acceleration is negative. And the way we say negative with math, less than 0. Okay, so we got to get in the habit of writing with math. Okay, so giving it math explanations. What is the maximum height the rocket will rise? Okay, so your position equation, I'm going to rewrite it right here so you can see it. is negative 16t squared plus 114t. Now we're going to do a bunch of stuff later to figure out how to actually give a maximum, but you know this from Algebra 2 even. This is a parabola. Negative 16t squared plus 114t is a parabola that opens down. The maximum will happen at the vertex. Well, calculus-wise, that would mean what would be the slope of the tangent line? Well, the slope of the tangent line would be 0, okay? So that's a little work on that. So basically what you're going to do is you're going to say that we want to find when s prime of t equals 0, and then it's a calculator question, remember? So you just have to say s prime of t equals 0 at t is approximately 3.563, because that's what you get in the calculator. And we give 3 decimal places in calculus, always. 3 decimal places. You can give more, but we always give at least 3. So then that's when it happens. So this is part of our work. So we're saying the position equation, the derivative is 0 at this moment. That means that's the maximum, that's when that happens. But it didn't ask for that, it asked for the maximum height. So then you would say S of 3.563 is approximately 203.063 feet. And then we would want to answer the question, and we would say the maximum height the rocket will rise is about 203.063 feet. But this is all the work that you show when you have a calculator question. Okay, so you don't have to do intermediate steps. You don't find the derivative and then show that you set that exact equation to 0 or anything. You simply say, I'm doing s prime of t equal to 0, and that's what I got. That's what happened. And then I need to take s of that number, and this is that answer. And then I want to actually answer the question, so I would say the maximum height of the rocket is about 203.063 feet. And you don't have to write big full sentences, but you need at least, you could say max height of rocket is about, and then write 203.063 feet. Just be sure you have units and that you answer the question. Okay, what is the speed of the rocket when it hits the ground? So when is it going to hit the ground? Well, if this is the position, then the position would equal 0 if it was on the ground. Not the derivative equal to 0, but the position itself would be 0. That's how I know it would hit the ground. So again, it's a calculator question. So you say s of t equals 0 at. You just do it in the calculator. T equals 0 or t equals 57/8. You can write the decimal down or you can write the fraction. Well, 0 is where it started, so that's not what I need. I need to use the 57/8. Then they ask, what's the speed? Well, the speed is the absolute value of velocity. So we want the absolute value of the velocity at 57/8. So that's what I will write. Absolute value of velocity at 57/8, which is 114 feet per second. And then you should go ahead and say the rocket is going about 114 feet per second when it hits the ground. Okay? All right. So that's all we're going to do on this, this lesson. And so anything else we need to do, we'll talk about in class. So that concludes our video.